Good afternoon. Today we're continuing on the idea of exploring the Munsell Color system. Remember yesterday we discussed the main ideas behind the Munsell system, which were, you remember, the chips themselves and how they relate to colors in the third dimension. So today what I want to do with you is just continue on and show you some aspects of the system that are interesting for many reasons. So first let's start with this spreadsheet in Microsoft Excel, and in this sheet I have captured all the Munsell colors that are in the Munsell Book of Colors I showed you yesterday. And over here are all the different colors that I have captured. For instance, 5YR92, which is a maximum of the orange, yellow-orange hue at a value of 9 and a chroma of 2, and it continues on this way. This is 5R88, meaning a value of 8 and a chroma of 8. Now right next to this, right next to each color name, is their LAB value, and right next to these are the spectral values from 300 nanometer up to 780 nanometer. And there's a page like that, a sheet for each color, each page in the original book. So there's a YR page, there's a 10RP page, there's a 5RP, there's 10P, there's 5P for the purple, and purple blue, and 2.5 and blue, and so on. So what I did, once I have all these colors captured with my spectrophotometer, then it's a matter of exporting the values. And one of the first things that I want to do once I export the values, let's see if I can have the values here. These are the exported values. You see, exported as a text file. So you see the content here. There's my name and the instrument that was used, and it's exactly the same value, as same numbers as before, but in the text file, not inside Microsoft Excel. And I had made another export which only contained the L, A, and B value. This is what you're seeing here now. Now what's interesting, once we have these numbers, is we can plot them in the third dimension. So let's see, I have here a software called ColorTink, and in ColorTink I believe I can drag the ColorTink window inside here, the viewport, so you can see this better. And this is the ColorTink application. It's got many uses. Believe me, it's one of these things that I love to have, and I don't regret paying the price for it because it's so useful all the time. But these are all the Munsell colors that were exported as LAB colors. So we have a point for each of the exported colors. There's over, I think, 1700 or 1800 colors in the Munsell Book of Colors in all. And as you can see, as I'm rotating these colors in 3D, in third dimension, it goes from darkest at the bottom to lightest at the top. And you see there's some kind of a ring that repeats itself on each line, each value line actually. You see, this is top one must be 9, value 9. This is value 8, value 7, value 6. This must be value 5, value 4, value 3, and value 2. There's no value 0. I guess there is, but it's a matter of which difficulty in manufacturing. In theory, it's possible to have value 1, but I never seen it. It's in books like Wijeki and Stylus. There is a whole series of table on these colors that are calculated for, you know, color work, colorimetry. But in practice, you know, it's in terms of actual paint chips. These chips in the Munsell system that I've measured, that are part of my book, are what's achievable, what's feasible. So that's one way to visualize these colors in 3D. I think it's useful. I think I like it because it clearly shows the position of some of the hues, like the yellows over here and the blues over there, and you get the sense of this 3-dimensional order of colors. And you have the gray axis in the middle. So now let's turn over to this piece of software, which you can probably still find somewhere on the internet. It's from an Italian university, and it shows the system in two different sort of graphics. There's this one, which show, as I click each value, it will show me the chroma is at the bottom, 0 to up to 38. That's huge. And then the value, just like the sheets of the books I showed you yesterday, they're organized the exact same way from top to bottom, highest value, lowest value, and then from left to right, progressive chroma content. So over here we have the RGB value, but we have also the HVC, hue value chroma notation. So we're in the leaf that's called 10G. 10G is over here in the green, so it must be where? Usually 10G is over here. So this is the hue that we are viewing right now, and this shows you all the colors that are also viewable from that view plane, value plane. Sorry about that. So this is we're on the value plane 5. If I keep clicking anywhere in that value plane, that won't change this graphic. But if I click on the value plane 9, you see all of a sudden this, like, it's restricting only the chips or the colors that have a value 9 to be visible here, of all the possible hues, all the possible colors. So you notice that value 5 is pretty much the largest of all the values slices. Intermediate, medium colors is always a very big part of all the colors that we can see. Value 2, and so you only have very dark colors over here. Notice the purples, the browns are here somewhere. And let's change over to, again, value 5, and let's click on, let's say, 10B. On 10B we have the blue. On BG is blue-green, and you notice that now what I'm doing is I'm rotating around the U circle, because this is what it is, a U circle. It's just the way that it's graduated. It's how Mr. Munsell viewed it. Mind you, originally all these colors had to be scaled, and Munsell had some ideas on how to do that. Actually built the very first photometer to measure value, but over the years the Optical Society of America decided to rescale all these chips and give them change their notation. Notice also, as I'm clicking and clicking away, this little software also calculates the equivalent RGB number and the equivalent XY. That's Y. That's the chromaticities over here in X and Y, and the relative luminance or the luminance factor over a scale of 0 to 100. And we have it the LEB of each of these colors. So Munsell is a very good system in my opinion. And let's see one last example. This one is coming from a software called Babel Color. It's called CTNA for Color Translation and Application. Now, if I open up the RGB tab, this is what I get. In this software, we can use different RGB spaces and do different kinds of things and to convert between one RGB space over to another RGB space. It shows the before or the after, and it shows at the bottom here some delta E, the metrics. And there's an input mode, and there's a few interesting things. But what I want to show you today is that also has something called Munsell, and another one which is popular in Europe called the RAL. The RAL system, which has its own notations, and I don't want to get into that because I'm not a specialist into RAL. Now, what's interesting is what happens here on this left scale. This scale here shows all the colors from all the Munsell colors from the red. You can visualize this is a color wheel. So if we go from red to yellow to green, and you notice some of these greens are greens that are only sort of visible on a computer monitor, because Munsell colors can be applied to more than just reflective paint or chips. And so what I have over here is 5G 8928 AGC 5G 828. That's a lot of chroma. As I'm pressing here on the saturation, we can decrease the saturation, or increase the saturation, or change the hue, and we're actually moving around the circle. And you see the chip here is changing position. It's showing us where the color actually lands in the chromaticity diagram. And this triangle here over here shows the selected RGB space. So if I select Adobe RGB, it's a little bigger than Apple RGB, and the biggest one is always ProPhoto, because ProPhoto uses imaginary primaries. This primary and this primary are not real. Only the red is real. So if I can select a color, it will show me the color inside ProPhoto. Okay. Now, okay, there's all kinds of things that can be made with Babel Color. It's a beautiful application. There are always other interesting things, especially if you have an i1 Pro. I highly recommend it. There's a lot of things that can be done with it. Now, want to show you now the applications of this. Now, once we have the opening up InDesign, you don't see all the menus. You only see part of it. Maybe I can resize the window so you can see it better. To my right, to my left, the top here. I gotta go through the bottom. Bear with me. I'm getting there. Should have resized this before, so would have made better use of our time, but it's always like that. So this is about what it is. So let me close down this window, and let me bring this one here just a tad. Over here we seem to have a blank page. We're actually into InDesign. This could be InDesign earlier version or a new version, and the page palette shows that it's empty. There's only one page into this document. Now, why on earth bring this into InDesign? Why bring InDesign? Because InDesign does not have built-in support for Munsell Colors, but it's possible to import all the Munsell Colors through an option here in the swatch palette. Let me see if I can bring out the option. It's called Load Swatch, and under Load Swatch it will want to have a special file format library. Now, I managed to convert, remember earlier, I had these colors, which are, you can't see now, these text colors that I exported from Excel. These numbers, these LEB numbers, I exported them and I managed to import them inside a library format that is compatible with Photoshop, with InDesign and Illustrator. So what I'm showing you now is the import inside InDesign. So we have all the chips. See, 2.5R, which is a red, value 9, and chroma 2, 7, 2, 2.5 here, 2.5, 6, 12. Let's just double click on this number to see what's inside. This is the swatch options. So as you can see, I have the LEB value with 2 decimal numbers. So this is how I entered the color inside InDesign. There's these other sort of library like the Pantone Colors, which are popular with designers because this is often all they're shown in school, and it's true that printers often work with Pantone colors. Some brands, Coca-Cola or others, use these Pantone colors, but they're, in my view, limited because they don't relate to perception. If I say here 2.5R, you know that this is not the maximum red. If I go to 5R, you know this is the maximum red that can be made into the system. If I tell you I have a 5R 514, for instance, let me draw a little object over here with this color, 5R 514. This is this area. This is what this color represents. This is filled with this color. The color that is used to fill this rectangle is Munsell 5R 514. It's an LEB color, and there's not going to be a problem when exporting to CMYK or RGB. Doesn't matter because the colors will be converted from LEB anyway. And same thing with Pantone numbers now. So there's no difference in InDesign or the Creative Suite working or with Pantone numbers, because the Pantone numbers, the Pantone libraries are distributed in LEB as well, and when exported, they export it in CMYK or RGB that are relative to the ICC profile that's assigned to the document. So in this case here, I have sRGB for RGB, and I have US web coated, sorry, let me change that quickly, coated Grackle 2006. And for the solid color intent, I could use absolute colorimetric rendering intent. So my colors will be converted from its lab value to either RGB or CMYK using absolute colorimetric intent. So that's the beauty of this. Now let me show you another view on remember these pages. This is exactly the pages that we were viewing, I was showing you yesterday from my book. Let me change tool over here, and I'm on page 18, and you see each one of these chips are exact reproduction of the chips inside the book. So this is the color 5RP, red, purple, value 6 and chroma 6, and the LEB number is right below it. And as we progress from left to right to right to right, we get into more saturated colors. And as we progress from top to bottom, we get into darker colors. So this is the page called RP, 5RP. So it's a red purple. If I go to another page, you see at 2.5p, I'm in a purple page. And if I scroll up here in the swatch palette, I can the page palette, I can get to other pages. Now what's interesting is what we can do with these colors in terms of design. So this is one application. I want to show you another application inside Adobe Illustrator. Hopefully I can bring this up, and let me go back to the very first here. So the very first page here, I'm just going to have to again arrange my window so that it fits inside this the area I selected at the beginning for viewing with my little application. So this is, let me get to the hand tool so I can scroll up or left or down. So you recognize this is Adobe Illustrator, and right now at the bottom you see the document color profile is sRGB, but because I'm inside an RGB document, I could be inside a CMYK document, it wouldn't matter. So you recognize here the Munsell colors I have. It's not all of them, I only selected a few because I only used a few for this this illustration. But at the bottom you recognize that what I showed the swatches individually. So 5B is 5 blue, 484 is a 4 is relatively dark, it's darker than medium gray, let's say, and 8 is this level of saturation or chroma. So I have blue, and over here I have yellow. I have yellow. This was yellow. The difference we got, you see, it's easy to tell by the number because this yellow has a value of 7 and this one is value of 8. Both have the same exact chroma level, 10 10, but this one is darker, and you can see it has interesting applications. For instance, the green I use, 5GY, green yellow 68, which should be this green over here, 68, that's exactly it. And then there's the inside of these letters. The letters are made with a lighter shade of green. See, it makes sense now. If I want to add contrast, if I want to make things stand out, it's easy to just change the value because I'm going to creating a lighter color. And if I want at the same time give it a higher chroma, more pop, it's easy to just crank out the chroma. Okay, there's a second one I want to show you. It's actually coming from a Starbucks campaign for their coffee that I recolored myself. So there's here 10B for 6, 10R is a red, 10R again. You see 10R 310 and 10R 24. See the difference between these two? Funny that this must have forget something over here. Let me see. This is 10R 24. This is 10R 310. There's not a big difference between the value over here, but this is usually saturated and this is not very saturated. So that's gotta be the difference. 2.5R is another staying around the reds, but it's now shifting. It's less red in a way. And this one is a higher value, so you can tell that it's makes the motorcycle stand out more over its background because the background is darker. It's darker because we know by the numbers that we're using that it's darker. Another one over here as well. This is like this one is from Kenya Coffee, and if I switch over quickly to an outline view, this is all vector, and as you see now, I'm gonna go back to it's called GPU preview, and all the colors now are in Munsell. See, if I select this color, it goes away, and this color is 5P28 and so on. All these colors are Munsell colors, and they're chosen according to some Munsell harmony rules that with different chromas, equal chromas, opposed used on the color wheel, which I should explain in a future video. Last example, this one is Panama La Florentina. So this one has a number of interesting Munsell colors. You see, it's far from being limited. It's a matter of understanding what the system does and how to use it, but it's certainly not out of reach of most designers. It doesn't take long to understand the system. So thank you very much for watching, and if you have questions or if you're interested in getting a copy of this library, please just drop me a line and I'll be glad to help.